Hi, today we're going to be talking about atmosphere. This is the second topic of the AP curriculum. When we go through and we deal with atmosphere, one of the things to keep in mind is that the atmosphere is heated by the sun. The space between the Earth and the sun really doesn't vary that much. It's more about the angles. When the angles hit, like here, directly on, we end up having a lot more heat and a radiation actually occurring. If it hits at an angle, then we end up having a significantly less amount of heat, which is why the equator tends to be warmer than at the poles. Now, one of the other things to keep in mind is the energy from the sun does a couple of things for us. So obviously the sun heats things up, and since it heats up the air, it causes that air to move because warm air rises. The other thing the sun does is by heating it variably throughout the year, we end up with seasons. And all of that sun and the movement of air, all of that actually ends up affecting our weather and our climate. Now, close to the equator is where it's going to have the highest level of solar radiation, not because it's actually closer, but again, the sun is hitting at almost a 90-degree angle. And so you have more direct sunlight per square inch than in other places that the sunlight's hitting at an angle. So that solar energy, it does actually create the seasons because the Earth is tilted. If you look here in the diagram, the tilt is kind of going like this. Each hemisphere tilts towards the sun for half of the year. So when the northern half is tilting towards the sun, we get summer. When we're tilting away from the sun, we have winter. The equator doesn't get a tilt, doesn't get seasons, so it's the same 12 months through the year. Now, solar energy actually causes the air to circulate, and so one of the things to keep in mind is that hot air rises. So what we end up seeing is down here by the Earth we have all of our water, we have the ocean streams, swamps, all of this stuff. So the air actually picks up a lot of moisture. The other thing that happens is all of that radiation, all of that sunlight is hitting stuff, and it's warming that stuff up. So the air that's sitting down here near the Earth, right near the ground, is not only getting wet from all of the evaporation, but it also is getting hot, where we have a transfer of heat. So that hot moist air actually rises, and as it rises, it cools off. Well, as it cools off, we end up having condensation occur. Condensation then ends up causing precipitation. Now, that cold air is stuck up here, but there's still hot air coming up. So as that hot air continues forcing its way up, it actually pushes the cold air that has already lost all of its water, pushes it off to the sides. And so then we have this cool, dry air that's sitting off here to the side, and as it's sitting there cool and we have all of this hot air coming here and we have more air pushing it, it actually, because it's cooler, cool air sinks. The cool air slowly condenses, slowly sinks down, and it begins warming up as it gets closer to the Earth. And we end up with some warm, dry air because it hasn't picked any moisture up yet. So then that warm, dry air is sitting right here, and it slowly moves into areas that had been losing its air because it had been evaporating and moving up. And we have this warm, dry air move in and into the areas and start picking up moisture. Okay, this is called convective circulation. Warm air rises, cool air sinks. We end up with these vertical currents that are both going up of warm air and down of cool air. It influences both weather and climate of different areas. Now, when we talk about our atmosphere, one of the other big things to talk about is circulation, or is composition. When we look at our air, we have about 78% of our air is nitrogen. That's primarily what we are breathing. This is why when divers go diving and they use compressed air, they have to worry about the bends, because that nitrogen, if you come up too fast, it actually ends up expanding a little bit faster than oxygen does, and you can end up with bubbles in your blood, and that's called the bends. But this oxygen, which is our primary one we want, is actually only about 21%. After that, we've got argon, which is pretty stable at about 1% of our air. So now, sometimes we can add in water vapor here. Water vapor has a big range. If you're in a desert, we have very little water vapor. But if you're in a swamp and you have high humidity, we have lots of water vapor. So we don't usually include this in our general composition thing. We also have traces of carbon dioxide, neon, helium, and methane. So those are what the air is made of. And this is the air of the troposphere, down here where we're breathing and living, etc. So our troposphere is where we are. It's where planes fly, it's where weather happens, it's where all of our clouds are. Now the troposphere, the higher you go, the colder it gets. Then we hit the line between the troposphere and the stratosphere. And one of the things to remember is the atmosphere is made of gases. And these gases, the troposphere, this is our composition here for the troposphere. Just like water tries to go down and pool at the lowest level, gases do the same thing. So this mixture of gases is denser than the other layers. And so consequently, it pools down and it forms the next layer. So the next layer up is the stratosphere. This is our ozone, okay? This is the O3s. The ozone layer blocks our UV rays, and so even though it's really, really cold here, as you move through the stratosphere, you have less and less ozone layer between the air and the sun, and so you end up having more and more warmer temperatures because that radiation is actually not being reflected, and so it gets warmer and warmer. Then we hit our mesosphere. At the mesosphere, the mesosphere actually then begins dropping in temperature again. So we then go down and we get extremely cold in the mesosphere. And then we hit the final one, which is the thermosphere. The thermosphere is our outermost layer. It gets extraordinarily hot. There's basically nothing between the thermosphere and the sun. And it actually, the far closer you get away from the Earth, it gets into astronomically hot temperatures. So that's what our atmosphere is kind of made of, how its structure works. So now, with this atmosphere, the atmosphere is actually what ends up giving us our climate and our weather. So weather is what's happening right now, this week, what's happening here versus Baltimore or North Carolina. When we talk about climate, climate is a broad pattern. In North America, we have 4 seasons. We have cold winters, we have warm summers. That is a climate issue. When we look at the eastern seaboard, we tend to have cold, wet winters. Whether we have rain or snow, we usually have some kind of precipitation. It's not cold and dry. And that is considered our climate. Now, if you've never gone through and found out about this, it is worth knowing, which is the difference between high pressure and low pressure systems. So a high pressure system is one that brings fair weather. It's around 30 and 90 degrees. These are going back to our picture here. This is this cool dry air dropping down. The high pressure system, this ends up pushing things down. It had this big pile of air there. It's actually falling downward. So it's up high and it's coming down, and it brings fair weather. Because remember, it was all dry. All of the water had already precipitated out. We see this primarily around the 30-degree latitude and 90-degree latitude lines. Now, a low pressure system, these are the ones that are, it's warm and humid. These are the ones where we were down here with all this moisture and we're about to have it evaporate and we get precipitation there. This is occurring around the 60-degree latitudes, both north and south. The air moves towards these low things. They are low pressure, and they are actually going to have that air heat up, and then warm air rises, and so there's air constantly moving towards them. So it's a low pressure system. Now, when we talk about globally, when we talk about this, as I was talking about the latitudes, there is, we refer to each of these latitudes as a cell. And if you look here, you kind of see these little bubbles at each thing. There's 3 cells in the northern hemisphere, 3 cells in the lower hemisphere. The ones by the equator are called the Hadley cells. The ones that are the kind of middle cells of the northern and southern hemisphere are the Faro cells. And then finally up at the very, very north, the poles, are the polar cells. And what it does is these cells actually interact. These are where we have the warm air rising, cool air falling, making these little tunnels of air. but they're also interacting with the Earth because the Earth's spinning and the equator moves faster than the poles because there's more distance for the equator to cover in the same amount of time. So because that's rotating and the air that is closest to the Earth is rotating with the Earth faster than the air that's higher in the atmosphere, and as it's closer to the equator it's going faster than away from the equator, we end up having this spin, and we refer to that spin as the Coriolis effect. And what we see is this north-south air currents end up making these convective cells deflect from a straight path, and we end up with these curving global wind patterns. So what we see is generally the wind tends to move to the right in the northern hemisphere as far as which way it's circling, and to the left in the southern hemisphere. And if we look here, the difference there is if I was standing on the north and I throw a ball, it might look like I'm going right, but if I was standing exactly upside down on the South Pole, that same ball, that same trajectory would end up looking like it was going left, just because my perspective had changed. So as we go through and we're looking at these patterns, what ends up happening again, warm air rises, precipitates out, gets cold, pushes down. So when you look at this globally, we end up seeing these cells. So at the equator, warm air rising, cold air dropping. Okay, warm air rising, cold air dropping. And so we end up with these 6 tunnels of air. And what this does for us on the ground is if I'm sitting on the ground at the equator, it's almost no wind. But if I go just a little north or just a little south, what it feels like is all of that wind is moving towards the east, because that wind is going to go this way and it's going to move like it's going towards the east here as it's rising, and then as it falls down here, it is going to end up feeling like it is rotating towards the west. And so we end up making a full circle of that air. Alright, to recap quickly, when we talk about the atmosphere and we talk about composition, we are talking about primarily nitrogen, about 78%, about 21% is oxygen. After that, you can have water vapor anywhere from 0 to about 4%. Argon is pretty steady at about 1%, and then we end up with carbon dioxide and some of these other very small amounts. As far as our structure, the troposphere, that's where we are, it's where our weather is, where airplanes fly. It's where the Earth's mass is. As you go up, the temperature decreases. We then hit the stratosphere, or the ozone layer. Okay, it's above the troposphere. It's really important. It keeps out 95% of the sun's harmful rays from reaching us. It prevents us from skin cancer, sunburn. It prevents O2 from being converted to ozone down here. We don't want to breathe ozone. We want it to be way up in the stratosphere. We have so in the ozone layer there's a lot of water vapor, and the temperatures actually increase as you go up in altitude. Then we hit the mesosphere. The mesosphere has very little in it. It's the coldest layer. Temperature then drops as you go up until you hit the thermosphere, which is our uppermost layer, and then temperatures increase as you go up. Alright, going on, we then talked about weather. Weather is the short term. Is it hot, cold, raining, hailing, what's going on? It changes anytime air changes. If we have one air mass, warm or cold, meeting another, we then have movement that occurs. If warm air meets cold air and it comes in slowly, then we call that a warm front. If cool air moves in quickly, we end up having thunderstorms, and that's called a cold front. Changes can occur in the atmospheric pressure. We have high pressure and low pressure. It can lead to weather extremes. If you have really, really high or really, really low pressure, we end up seeing things like tornadoes, hurricanes, and typhoons. Real quickly, hurricanes and typhoons are same thing, different oceans, so they are called different things. So the Atlantic Ocean calls them hurricanes, they're called typhoons in the Pacific, and they are called cyclones in the Indian Ocean. Alright, climate is our regional temperatures. It's our regional general weather conditions over a